Hello, I am Rupesh, a principal consultant at Ingenious Brand Solutions. Today we'll be discussing the product lifecycle assessment, wherein we'll be largely talking about how to assess and estimate the environmental impact of various products and the processes across its life cycle. So the product lifecycle assessment is the method of estimating the environmental impact of the product over its entire life cycle. And to do so, we have to cater into the carbon emission, carbon equivalent emission, water consumption, or the chemical consumption. Furthermore, when we look into the emissions, we have to consider it across various categories like the scope 1, wherein we look into the direct emissions, which are the emissions that are happening within the facilities of the organization. The scope 2, in which we look into the indirect emissions, for instance, the electricity purchased or any other emissions that are happening within the setup of the organization but being procured externally. The scope 3 emissions, which are all other indirect emissions, which are neither within the ownership nor under the control of the organization, but they are responsible for the same. Also, we cover the various stages while commencing this kind of assessment, like the material processing stage or the logistics stage or semi-furnished product assembly or the final product assembly stage, distribution stage, end use stage, and recycling stage. But also when we cover the various business, depending upon the business nature, we have to consider the different approach. Like for B2B businesses, we look for the cradle to gate approach, in which we cover the stages starting from the material sourcing until the product reach to the final facilities of consumption. And for B2C businesses, we look into the grade to grave approach, in which we additionally look for the end use as well as the recollection and recycling stages for understanding the overall carbon footprint. So let's talk about some of the benefits that the LCA study offers, as well as the goals that are being achieved by the companies after they conduct the LCA studies. As we all know, the different organizations as well as the governments across the globe have set up their decarbonization and carbon neutrality goals. And the very fundamental stage of enriching this journey is to first understand what is the carbon footprint that your existing product and the processes are leaving behind. And that's what the first benefit we are talking about, is to determine the environmental impact of the current products and the processes before they initiate any decarbonization journey. The second benefit is to understand the worth of product across each stage of life cycle. Since we will be analyzing the processes across the different stages of life cycle, we will also be considering what value being added across each stage for the product development. The third one is to optimize the operational cost. Since we'll be analyzing the processes across the different stages, we'll also be understanding the productivity efficiency of those processes, and eventually we'll be understanding what is the costs are associated to it and what is the possibility of generating profitability out of it. We also look for the possible improvisation and upgradation within the existing product, and ultimately all of these fundamentals would contribute to develop a sustainable journey for the organization. So let's talk about the goals that are being achieved by the companies. The first one is the better strategic decision making. So once the life cycle assessment is done, they are in a better position to prioritize the different processes as well as the different vendor relationships so that they can meet their sustainability targets. The second one is to support the sustainable development, further be relevant and in line with the other partners within the supply chain, since everybody is now having their own journey for the sustainability. They would want to their partners and the vendors to follow the same. So to be in sync, to understand the potential of the business with those partners, there needs to be the life cycle assessment conducted first. Improvements in the overall production processes, as well as gain the competitive edge in the markets, are some of the other goals that are being achieved by the companies. let's look into the methodology, and the very first step of the methodology is understand the guidelines that are given by the different ISO standards. So a couple of ISO standards that talks about the ways through which we can define the objective of the studies, what are the different methods of estimating and interpreting the data that are available or that are being exist. Some of the ISO standard that talks about what kind of inputs and the outputs are required for effectively conducting the studies, what are the different interpretation as well as the reporting methodologies that needs to be followed, and some of the ISO standards that provide guidelines around other crucial aspects like considering the pre and post consumption scrap or carbon offsetting processes, etc. So when we talk about the detailed methodology, the step-by-step approach for looking into the life cycle assessment, the very first stage is to understand what are the process involved in the product development cycle. The second stage is activity breakdown. So across each process, what are the activities are available and what kind of different level of energy consumptions that are required across these activities. Then we have to actually finalize the approach, like which all factors that we need to consider, which can be omitted considering the negligible impact of it on the process. Thereafter, we'll be looking into the components of the study, like if we need to focus only on the carbon footprint or if we have to consider the other carbon footprint equivalents on the water consumption or chemical consumptions across the selective stages. And the last one is the overall carbon footprint and the estimation, as along with the water estimation as well as the chemical consumption estimation. So generally, when we talk about the carbon footprint and the carbon equivalent, we cover all the stages, but for the water consumption and the chemical consumption, it is majorly restricted to the material, raw material acquisition stage as well as the manufacturing, the processing stage. This is these are the stages which are then process dense, and there largely we see the water consumption and the chemical consumption. When it comes to the methodology of raw material acquisition stage, we consider the different materials that are being consumed, the volume of those materials, what are the carbon emissions across those materials, and if at all there are any supporting processes like the finishing or the packaging before the product is actually in a shape of consumption. Considering all these aspects, we summarize the overall carbon emission at the raw material acquisition stage. So in the logistics stage, we locate the different suppliers facility as well as the different production facilities, and we analyze the different routes as well as the modes of transportation, like be it the road transport, the air transport, the ship transport or the railway transport. Accordingly, we have to understand what is the efficiency of these all different routes of transportation as well as the modes of transportation, what are the fuels that are being consumed, if at all it is a certain level of the green fuels, or what are the overall sustainable impact of those fuel consumptions across the different modes of transportation, and then summarize the overall carbon emissions across the logistics stage. So in the manufacturing and processing stage, where the raw materials or the semi-finished products are being consumed at the different production facilities. So in those facilities, we have to understand the different processes that are responsible for the complete assembly of the semi-finished products, as well as the different other processes that are responsible for the final production of the products. And we also need to analyze what are the energies being consumed across these processes, what are other complementary materials that are required at this stage for betterment of the product. And additionally, we have to look into the infrastructure where we have to look what is the storage as well as the factory supporting elements and what is the energy consumed across these infrastructural factors, and then accordingly summarize the entire carbon emission across the manufacturing and the processing stage. Similar to the logistics stage, we also look into the distribution at the transportation stage, wherein we analyze the distribution routes from the production facilities towards the consumption facilities of those products. And in the similar fashion, we look for the different routes, the mode of transportation, the infrastructure availability, as well as the fuel that is being consumed, and then summarize it with the carbon emission factors to turn up into the overall carbon emission across this stage. Lastly, we look into the after use stage, which is where the products are being recollected and recycled and uh, ultimately being used in the new production facilities. So there are different product categories like the chemical products and the mechanical products, and accordingly we have to look into the different processes from the chemical recycling side as well as the mechanical recycling side. For instance, let's take an example of the mechanical recycling, wherein we have to consider the several processes like the collection of the material, the sorting of the material, the packaging, and the entire recycling processes like the washing, drying, pelletizing of the materials. And across each material development stage, we have to consider the energy requirement as well as the other supporting material requirement and figure out the carbon emission factors for the same, so that we can understand what is the entire carbon footprint that is observed across the recycling stage of certain amount of products when they are being recycled. Similarly, in the decomposition stage, we have to consider the process like collection and burning afterwards. If it is the gas waste, then there has to be a separate process to it, and if it is a solid waste, there has to be separate process to it. But the agenda is to understand all the processes in detail so that we can estimate what is the necessary energy requirements across these processes, what is the necessary supporting elements required across these processes, and for all these energy consumption and the supporting elements, what are the carbon emission factors that are responsible for the carbon footprint equivalent estimation, which needs to be considered and counted into the total carbon emission across the decomposition stage. So when it comes to the analysis, we would be looking into the various structures. Like the very first one is to understand the carbon footprint across the different stages in the form of percentage as well as the actual numbers. So you can see the certain amount of carbon is being emitted across the raw material acquisition stage, a certain amount of carbon is being estimated across the logistics stage, so on and so forth. We can also look at the possible analysis for the product comparison, like if we are considering two different product categories or if we are considering two different processes, which one is estimating higher in terms of the carbon emission, which one is estimating lower in terms of the carbon emission, and accordingly prioritize the production of those products. So before we conduct the life cycle assessment, we need to have a multiple data pointers to be collected before actually commencing the study, which are coming out from the different stages like raw material acquisition, logistic, manufacturing, etc. And there would be a role of different parties involved in it for procuring and uh, sharing the data, like the client or the organization itself who is conducting the life cycle assessment. They need to look into the different internal departments and analyze what all data pointers they would have in terms of the processes as well as the uh, materials that are being procured, etc., We also have to involve the vendors which are supplying the different components, be it in the raw or the semi-finished formats to our client, and understand what are the sourcing of their material, how they are developing those materials, and what is their, uh, if at all, any energy consumption requirements that they have. We need to, analyze those factors as well. Along with that, we need to look into the different channel partners as well, which would be responsible for the transportation and the distribution facilities. So all of these factors come together before we start any study, so that we have all the necessary data pointers with us, and then accordingly we have to look into the details of those data pointers, see the similarities, see the gaps in the data that is available, and accordingly try to fill it in the frameworks of the analysis.